My name's Jack Klecha. I'm the Vice President of Enterprise Information Security here at Cisco.
And I'm John Woolwine. I'm Vice President of Networking at Cisco IT.
So super excited. We usually we're on calls. We're working on projects together, but it's kind of fun. Over the years to as much as we work together, actually sitting down and talking about what we do.
Yeah. This is a little different than what we're used to. Usually we're doing some kind of a planning exercise or alignment exercise, and here we are talking together about what we're doing, what's working, what the challenges are, and what the future looks like. So you and I, we know each other. We interact pretty regularly, day to day at Cisco. You are part of the information security group at Cisco. I'm part of the networking team in Cisco IT. There's a natural synergy between us. Would you agree?
It is, yeah. It's been a fun journey too, right? It's I think back when I first joined, and we interacted when there was something going on, and we had to get involved and partner on stuff. And then as we got to work more and more closely together, it's a little bit more of a partnership.
Yeah. And so, okay, over the last few years, we've known each other, and the threat landscape has changed quite a bit. You want to talk a little bit about that, your view around that threat landscape and how it's changed?
Yeah, there's a lot of places I could go with that. I think historically we were protecting against something that we could kind of understand in terms of known perimeter, legacy. We're talking, there's a enterprise, there's firewalls, there's people inside it, they're connected in internal services. We pivoted, we started moving more to SaaS and cloud delivered capabilities. Hybrid work's a big thing now. People are working from anywhere, connecting to anything. You throw in IoT, now you throw in AI. Everything is swirling around us, right? The technology is there for us to do some really cool stuff. That same technology is out there for attackers to do some really cool stuff, right? So kind of if I sit back and think about the landscape we've got to defend collectively against, it's really complicated now.
Yeah, and so you mentioned IoT, right? IoT, that takes us back 10 plus years, right? We've been, seeing more and more IoT-like devices come into the network, even in carpeted space, in buildings where our employees work. But that's slowly been building up over time, and we have adjusted security appropriately around that. AI is new.
100%.
AI is very new, and the pace at which AI is moving is much faster than anything we've seen before. So how does that make you feel from a security perspective? Is it keeping you up at night?
Oh, 100. Yeah, it keeps me up every night, and it's interesting when we think about it too. So we've got the legacy world you described, where it's people are coming to the office, they're plugging in their IoT things, and it's a PlayStation, it's whatever access point or some things that they're playing with, and they want to connect a Raspberry Pi. That thing right there sitting on the table behind us, somebody could go plug that into the network years ago. We've cleaned that up, right? And we've got a pretty good handle on access to the networks. Those are things that we could look for and find and touch. AI is different. AI is software. It's running on laptops. It's running in data centers. It's running in clouds. It's connecting to data that we never envisioned. It's doing things on behalf of people. Sometimes it's doing things on behalf of machines.
Right.
At the end of the day, it's a super complicated environment that we've got to go deal with.
And what you're talking about are good actors trying to get their job done, right? But we have the bad actors that are also using some of these tools as well, and that are moving very quickly.
Yeah. I think that's the biggest thing I've seen change in probably the last year, and then it seems like every 3 months it gets even faster and faster and faster, right? Every version of model that comes out from our partners or from the industry, they're exponentially better than the last one. And attackers are doing the same thing with these models, right? And it's, a year ago we probably would have been that's kind of far out, that's a couple years away, but we just saw with, recent announcements from Anthropic and Cisco and others have been partnering there. It's pretty amazing stuff that's happening now in the AI side, especially when it comes to security.
Yeah. So the bad actors are moving at machine speed, machine scale. What do we do? How do we react to that?
Yeah, it's so the speed is really insane. I'll just put it that way. So if we look at historically security, we thought there was something gets disclosed, there's a new 0-day of vuln or something like that. It was days, weeks sometimes for exploits to happen. Like we're talking now from the time something's discovered to it's exploited, we're talking hours. And then we're going to be talking minutes. Then we're going to be talking like it's almost instantaneous. That's a tough way to play defense, right? Like we think about all the controls that we have and all the stuff that we have to do to protect Cisco as an enterprise. How do we do that at that speed now that we're facing from an attacker perspective? Right? That's the game changer for us. Like we don't have the luxury to say we need 4 days to go review something and figure out what we've got to go configure. We've got to go change that stuff almost immediately now.
Yeah, and I think about it on my side. I run the corporate network at Cisco. I'm not alone. I have a whole team behind me. But we think about this too, and over the past couple years, we've gotten much better at vulnerability management in the network and being able to upgrade network devices pretty quickly. You know, on the order of days, we can cover our entire fleet of network devices. But that's like, you know, in today's world, that's sort of not feeling fast enough. Like, it's really strange to say that, but I sort of feel like we're now behind the 8 ball a little bit in the speed at which we can move when it comes to like patching a network device, upgrading the OS image on a network device. I mean, I feel like we need to get from sort of days to maybe hours, or find different kinds of techniques to protect us. They buy us a little bit of time until we can do these upgrades.
Well, it's like I think there's two pieces there, John, as I'm thinking about it. So there's something going on that we've got to immediately respond to. How do we stop the bleed or mitigate whatever we're facing? I think that's where we're super excited. Live Protect and some of the capabilities that we're starting to put into Cisco's infrastructure. Those are the really quick, immediate triage, stop the bleed type of things. Keep us going until we have the fix, because sometimes we're talking about fixes that may take, you know, hours or days or weeks to get built, delivered. Your team gets an image, you've got to go test it, be able, like the last thing you want to do is go take something off the shelf that's a fix and then accidentally break something. And so like you can't react in the speed at which attackers are coming, right?
I'm willing to move fast and loose in like an office building, you know, that's less critical from a business perspective. A data center though, that's a different thing, right? You know, I need to be a little bit more conservative in a data center. So having capabilities, like you mentioned Live Protect, right? Something to buy me a little bit of time to protect the network itself until I can get in there and upgrade the network and address that vulnerability. That's huge for my team. That buys us a little bit of security and a little bit of time, and not sacrifice you know, the stability of the network by trying to move too fast and upgrade too quickly.
And I think that's the lens from okay, there's a new attack in the wild that we've heard about or found, right? That's going to buy us time there. The other thing that AI is doing for us, though, as we see, is now we're able to go attack ourselves or attack the code and kind of deconstruct and really get a much deeper look in trying to understand where are there weaknesses in the products. Find those proactively. See if we can exploit those, or the tools, obviously, right? And then what that's going to turn into, that there's going to be a bundle of bugs or vulnerabilities that are now going to be packaged, and now you've got to do a fairly material upgrade, but it's going to be a lot more. Hopefully the intent is that it's going to be a lot more stable. There's a lot more testing. There's a lot more, validation that everything is where it should be. And now, as a security practitioner, I could come to you, John, and say, hey, there's a significant set of changes in this product from whether it's us or a competitor or whatever. This major version is something we need to get on pretty quickly, right? And we're not going to try to nickel and dime you with like, hey, I need you to patch every Monday. Like, there's a big bundle of things. We need to move to this because this is the latest stable, really secure one. So as a practitioner, it's changing, like real time changing our calculus now, because it's no longer about vuln management and thinking we could fix a point problem. These tools are finding bundles of problems. And we need to think about it as fixing those big bundles at one time.
Right. So the context of what we're talking about here, just to make it really clear, we're talking about protecting the infrastructure, the network infrastructure itself. Right. So
if you can't trust the network, you can't trust the data going through it. Right.
Exactly. So why has the network itself, or what what's happened recently to make you think that protecting the network itself is critical for any business?
So I think it goes back a while, right? So what we've seen, and there's an uptick recently to prove this point, but for years, attackers were going after users. They're going after laptops. There was malware. So for decades, the industry's built anti-malware, antivirus technology. There's a lot of stuff we load onto a laptop to protect the users and protect something malicious from happening to the user. But the interesting thing is, like, if I compromise you, I compromise your laptop. I get access to what's on your laptop.
Yeah.
That's a lot of work to get what's on your laptop. Now, you may have like some really amazing stuff on your laptop. That's cool. But if I can compromise the infrastructure, I'm not compromising one user. I can see everything now going on, right? So I think attackers also, they're good, right? They know where the weaknesses are historically, like where people aren't watching, where we don't have as much telemetry historically. They're going after that, and now you compromise an edge internet-facing asset, and now you have access to whatever's going through that gateway,
Right.
or that load balancer, or
Right.
the firewall, etc.
Right.
And we're seeing that, like that. Those are the attacks that we're seeing in the wild over the last year. Right, you could go look at CISA or anyone else. Like a lot of the vulns and the emergency patching has been related to a lot of internet-facing edge devices. That's where the attackers are going.
They're going after the network.
Yeah, it's the biggest bang for your buck right now.
Right. So the old school strategies around network security, yes, you talked about the endpoints, the laptops, antivirus controls and things like that, right? And then in the network, you had your traditional firewall at the perimeter, right? Obviously, that's not going to work in today's world.
There's no perimeter anymore.
Right.
What's your perimeter? Like, you don't have one, right?
Half the company at any given time is working from some location. I have no idea where. Yeah.
Yeah, and so the other piece there is, like, there's the identity side of this too, right? So as we think about this, and this is how we, as an enterprise, we have to think about where our users are, who they are, who's their identity, where are they gaining access, and so that's another really critical part, because in many ways the perimeter shifted from a kind of a known kind of bastion. You get a firewall, here's your boundary, to now it's wherever your user is.
Yeah.
And the only thing you know about your user is their identity, typically.
Right. So not only users, but applications as well.
Yeah.
I mean, we've been talking about cloud for years and years, right? And we all know that applications have become incredibly distributed out there across multiple clouds, right? So it's kind of it's a unique problem, right?
Yeah.
You've got the applications that have become very distributed. The people and the devices have become very distributed in this hybrid work world that we're in right now. It's sort of like this any-to-any problem crossing networks that you don't necessarily own.
Yeah. You haven't even mentioned AI at this point.
No.
So like that's gasoline on this thing, right? That's the next big wave of things that we're coming. Like, it's hard enough to understand what's talking to what, whether it's people or applications, but now you've got a lot of agents that are out there doing things with a lot of skills that they're capable of using, and a lot of access to a lot of data and a lot of power. Right? Yeah. It's what used to be a fairly understood, and security's never been easy, and networking's never been easy, but you kind of knew what you're trying to protect.
Yeah.
Now you don't, right? It's a very different world, and like, how do you now apply controls and policies across all of those and not break something by accident?
Right. So traditionally, we think about network access, like authenticating and authorizing network access. That's kind of the first point of control in the network, is the point at which an application or device connects to the network. Now you got agents, AI agents connecting to the network. Do you think we need to take some kind of identity-first approach with agents in a similar way that we've taken with people and devices?
Yeah, short answer is yes.
Yeah.
The how, I think, is still being decided right now by the industry. I think there's a couple schools of thought right now. One is the world of John's got his own personal agent.
Yeah.
You apply your own identity to that agent, and it's just a virtual assistant for you, and it just acts and behaves on your behalf under your credentials. But now the challenge, there's pros and cons with that. One of the things as a security practitioner that makes that challenging is, if that agent misbehaves, was it the agent or was it John? I don't know. It was just your user ID.
Right.
And you're authorized to do things with this applications and the data that you have access to.
Yes.
We also see there's the other side, which is treating agents as kind of the non-human type of identity. It's not acting as John. It's acting as an agent that has similar characteristics as John, and it's similar that we do with machine accounts, right?
Yeah.
So like when you have automation scripts and things like that, you've got a lot of different things that I think we could probably marry the two worlds together and try to sort it out. But I think largely speaking, what we see and where we think it's going to head is like these will have their own identities. They're going to be non-human identities, but that's what we're now going to have to entitle, track, put controls around.
Right.
And the reality, like these are things that are going to be evolving like all the time.
Yeah.
It's not like when you hire, like we're not going to hire hundreds of thousands of people every day. You may be churning through thousands or hundreds of thousands of agents at any point, right?
Yeah.
Whether through a day or a week or a month, right?
Yeah.
So it's kind of a fascinating thing that we've got to think through.
Yeah, and so coming back to the network, what I start to think is some of the foundational capabilities that we have available to us today in the network that we've built out, controls around network access, for example, zero trust access. A lot of these things could potentially be extendable to agents, in terms of identifying what the agent is and applying a policy in the network that is based on the identity of that agent, and including a certain authorization policy as well, what that agent can do. I sort of feel like those foundational capabilities that we already have in the network today are going to become increasingly valuable in this future world that's starting to look more and more agentic.
So I was having a conversation yesterday with one of my tech leads, and that is exactly what we talked about. Like what we're seeing right now it's a pattern we've seen before. The difference is the speed at which it's coming at us, right? It's still, what has access to what. Like I used to talk, it's like who has access to what. We've done these projects, extranet and a lot of these other things that we worked on, and those are our core challenges. Like it's, okay, John is John on this device, he's reaching these applications and he's entitled and authorized to do certain functions. Now we're just doing that where it's not John, it's 1,000 things that look like John that just are agents, and each agent might have its own data source, it might have its own controls, but at the end of the day, it's still about who has access or what has access to what, and that's what we have to really control.
Right. And thinking about access, one thing that I think we both agree on is that having some kind of unified policy that can be applied universally across our network end to end, that starts to look more and more important, right? This is an increasingly complex world. Our ability to enforce policy very quickly and easily across an increasingly complex landscape, I think we're gonna need to put a lot of focus on how to do that going forward. It's starting to feel to me like that combination of unified policy plus agentic operations gives us the ability to sort of manage this increasingly complex landscape without relying on people. In today's world, a lot of it's human driven, right? Yeah. But looking forward, as we start to talk about an increasingly complex landscape, we should be dealing with this with machines, with agents, right? And this agentic ops concept starts to become a potential solution for moving very quickly to apply policy and ensure policy is consistent end to end.
Yeah, I mean, thinking about that, like, so what's our legacy environment? We've got 100,000+ employees and contractors, thousands of applications, hundreds of sites globally, numerous data centers, a lot of cloud infrastructure, and that's what, millions of ACL lines?
Millions of lines of ACLs, yeah.
And now we're talking, throw in exponentially more agents.
Yeah.
Talking to themselves, talking to more data sources, and we're gonna, we can't scale.
And not only
we
that,
can't scale our ACLs that far.
but these agents are coming and going and moving around, so static policy is not going to work. And thinking that humans can deal with that kind of a world is just unrealistic.
Yeah.
Humans can't scale.
I remember when we first started working together. I remember one of the things that our clients and then you would voice to us is, we have to get faster and better at just handling the policy changes. Mm-hmm. The business is moving faster. We've got to be able to keep up with them. That was before AI came along, right? So we don't have the luxury of, okay, you've got a 24 or 48 hour SLA to be able to say, you got a new business request coming in. I need this thing to go talk to this thing. Like,
Yeah.
we're talking like seconds matter now.
Yeah, totally.
And that's just on the happy path. Those seconds matter even more whenever we're talking about protecting ourselves from an attack now.
Right, right.
So, if there's something going on, God forbid, like we don't have days to go
yeah.
put changes in and
Yeah,
test
yeah,
them.
yeah.
Like it's like go now.
Yep, yep. So, okay, thinking a little bit about just policy in the network. Today's world is largely human-driven, right? We've got millions of lines of ACLs. It's a largely human-driven process when it comes to changing that policy. I may have 3 or 4 different places in the network where I have to actually implement that policy. I have to implement it in the access layer of the network, like maybe within ACI in our data center network. I have to implement it in a data center firewall. I also have to implement it at an edge firewall at the perimeter of the network, right? So basically what this means is this one ticket has to be passed team to team to team to team to team. You're lucky if you're getting this work done in a couple weeks, right?
Yeah.
And that's not acceptable in today's world.
And you think about it in an attacker's perspective, like we have to be perfect. We have to get all of those control points and all the policy deployed 100% correctly for it to work. Because it just takes one spot that we miss a little bit of control, and that's what the attacker's going to go find, right? It's interesting, like as I think back, and this is way before I got to know you, but like I don't know, early 2000s. One of the concepts I know Cisco was talking about at the time, and it seemed like very science fiction. It was like the shot to the it was a moonshot, or maybe even a shot to Mars, which is this notion of a self-defending network. And at the time, it's like, well, there's no. The technology's not there. We don't have enough signal to tell us what's going on. We don't have the compute power to process all that signal. We don't have the ability to push all this out, because that was still very CLI based, human configuration. But what you're talking about, that's right in front of us now, right? We've got, where it's agentic ops and all the data that we have, the unified policy control planes, like that's right here in front of us now. All right, so we've talked, John, about the complexity, all the technology that we've got. There's a lot of control points in the network and the speed at which things are changing. But a lot of that's tied back to ultimately security policy and the controls that we want to deploy across the network, right? So, tell me a little bit about like those challenges that you're facing, and specifically like how you're thinking about it differently. How does hybrid mesh firewall tie into that? And like, what's your vision and the direction you're taking? Policy management at Cisco.
Okay, let me take a step back. Policy management for my team used to look like an on-prem policy management system that was managing basically firewall rules, right? That's what policy management was for us several years back. But as we've talked about, policy's changing. Policy's becoming much more distributed, right? And it's common policy across multiple different kinds of network components. It could be policy embedded into smart switches. It could be policy embedded into firewalls. It could be policy embedded into Hypershield or hybrid mesh firewalls or Cisco Secure Access. So policy is becoming much more distributed. So what I'm starting to do is move towards more of a centralized cloud-based approach to firewall, or not just firewall policy management in general. And for us, what that looks like is Cisco Security Cloud Control being a central point at which I can manage any kind of network security policy anywhere in the network across any device or any cloud.
Well, and this is as a practitioner, like that's music to my ears, because one of the things that I think about is, us from a security perspective having to be right. And if we're not implementing consistent policy across, we may think we're good, and it just takes one spot that we're not, right? And that's what the attacker's going to find, and that's how they're going to take advantage and get in.
I would think you might like it a little bit better. There's fewer places where we have defined policy, right? You don't have to hunt all over the place and figure out what policy looks like end to end. We've got it all defined in one place.
Yeah, and I think you put on your help desk hat, or anybody troubleshooting what's going on, like that's the source of a lot of cases coming in, right? Which is, hey, something changed. I can't get access to this asset any longer, and nobody knows why. And it could be one of a litany of different policies that may have changed. And now you at least can quickly get to the core truth and troubleshoot and get the customer back on their way.
That's right. Less swivel chairing across different systems, more going to one system with an AI assistant that can help me. Kind of where my head goes when I describe that problem, that's feeling like That kind of a solution is actually feeling like the opportunity in front of us. You take the ability, you take a little bit of AI, a little bit of machine intelligence and machine speed, and you combine that with the ability to distribute policy across multiple places in the network in a unified way, and that starts to solve the problem that we were talking about before. I think that's a good example of how you take a little bit of AI and a little bit of network security and apply those two things in a unique way and solve some real problems for people like us.
Well, and like as you describe it too, it's really interesting though. Like as I think about it, you didn't say we were just like ceding all control over to the AI gods, right?
Yeah.
It's a little bit of AI. It's still people. There's,
Yeah.
or how are you? Are you like human in the loop, human over the loop? Like,
Yeah.
where are you right now, and where do you think
Yeah.
like are we heading around the corner?
Where I am right now in our network is there is a good amount of agentic ops playing out in our network today. Where I'm letting the team have a little bit of freedom is around like triaging, gathering information, pulling that information back in front of an engineer. I'm less comfortable with actually letting AI just independently make configuration changes or policy changes without some kind of a human in the loop. I'm not there yet. I need to build up a little bit of trust over time to get to that point. I think we can get there. But right now, it's mostly like human in the loop when it comes to configuration changes in the network. I want to make sure that we have deterministic configurations in our network. And the non-deterministic behavior of AI just leaves me a little bit concerned that if we let AI go against this network, it may be creating more of a mess than we're prepared to deal with.
Well, and it's a great point too. Like at the end of the day, we still have, like we have to govern. We still have to be able to audit and prove that we did the work properly. And if it's not determinate, like we'll be in a kind of this endless spiral of like proving why did this break or what happened here. And like at the end of the day, I think we'll get there.
Yep.
And actually, I'm excited about on our side, on the security side, which is all the signal and things that we see. How do we now more proactively use that? You leverage AI to more quickly detect and respond, and that response is like either connected to you, or sometimes we have to make the emergency cutoff switches, right? Because there's something going on. Whether it's the cutoff could be just use AMP to quarantine and then isolate devices, or kind of drop traffic or whatever it happens to be. But those are the things that historically were a lot of manual, a lot of late nights, a lot of coffee, and hopefully now we're in that world where the machines don't get tired, right?
Mistakes along the way too.
Exactly.
Let's just be honest. People make mistakes. We know that we don't have a 100% consistent policy end to end across the network. But that's where machines can help. That's where AI can really help us, I think.
Yeah.
So just thinking a little bit more about this agentic ops world, things like AI Canvas that can help pull information together and put it in front of our engineers very quickly. That's hugely valuable, even if AI Canvas is not actually making a configuration change to fix something. I think we'll get there, but right now, just that ability to pull information together quickly lets us triage any kind of security incident much faster. Whether it's a security incident or just a regular network incident, our mean time to repair can go way down, and our engineers don't have to spend as much time swivel chairing system to system to system to system. They spend less time doing that, and they can focus more on evolving the network and taking our network into the future, rather than gathering information from all the different systems so that over the course of 7 hours they can finally solve a problem.
Yeah, I think that you're hitting on something that's kind of interesting. It's plagued us for a long time, which is knowledge is power. You need a lot of telemetry and understanding what's going on. But when you put it all together, now it's really kind of hard. There's a lot of work to go comb through that. Like it's like literally needle in a haystack trying to find what you're looking for. But that's really what machines are really good at, right? And now you give, you triage and you prioritize and give your analysts, your engineers, your architects, like here's actionable things that we need to go off and chase. And it's not like, let's go stare at a bunch of noise and try to figure out where the signal is at this point.
Exactly. I think that's all true, but the foundation of this, the bedrock of this, is the data.
Yeah.
You gotta have good data. Like within my team, within the network team, what I think about is that I have to have rock solid data about the network itself, whether that's a network source of truth or a CMDB. Those are very foundational in this agentic ops world going forward. If that data is not accurate, the answers I'm getting back when I'm prompting an agent are not going to be accurate. And so I'm thinking about, the policy data has to be accurate, right? Network configuration data has to be accurate. Those data sources are actually, like I said, they're the bedrock of AI.
Yeah, we talked earlier, right? Like the one of the challenges that we've had historically, which is we think of security starting at the endpoint, and that's where we're actioning a lot of things. You only have the ability to see what's really going on that endpoint. You still need to stitch all this other stuff together. So like for us, it's, we have the ability to use Thousand Eyes or flow data off of our assets and off the network. We can see what's connected now, and it gives us like an unprecedented view of what's going on, right? And it's, in terms of troubleshooting and getting performance issues addressed, but also like if there's a security incident, we actually can help troubleshoot and isolate devices much more quickly, understand what the impacts of ACL changes are. And I think that's the place that historically I think we probably had to spend a lot of manual time to really kind of do that rapid threat model or risk assessment to understand if we apply a firewall rule change here to go protect this subnet, well, what did we just break? Because maybe you don't always have a perfect picture of all the objects or the assets behind those subnets, right?
Yeah. So I think the key thing you just said is humans stitching this information together.
Yeah.
That takes time. That takes effort. We don't have that time.
And that's the errors too, right? Which it's, we've all been there, right?
Yeah.
It's a Friday night or a Saturday evening and there's something going on. Everybody's on the bridges. We're trying to put the fires out and trying to understand what's going on, but people get tired, people get cranky.
Yeah.
But you know what? This is where the Gen Ops pieces are going to help us out, which is they don't care what time it is, right?
Yeah.
They're going to be able to go do their thing and help us cut through the noise.
Okay, let's switch gears a little bit. I have a new idea of something we can talk about. Segmentation, network segmentation, right? My view on network segmentation is it can be very challenging. Segmentation at a macro level, I think, is manageable for humans. Big security zones and securing access between security zones and applying policy between security zones. But getting to more fine-grained, granular kinds of access.
We call it micro segmentation, whatever you want to call it. Right?
Yeah, like you're in an enterprise with 2,000 or 3,000 applications, right? Thinking you can go into a data center and for, let's just say, 1,000 applications, like identify all the dependencies that application has and build a policy that not only protects that application itself, but isolates each component of that application to its least privilege access. That is hard work. That takes deep knowledge of applications. So what do you think about AI's ability to help us with network segmentation?
Yeah, I'll unpack that a couple of ways. So 100% agree. I think that's why a lot of micro-segmentation projects or fine-grained segmentation projects have stalled historically.
Yeah.
All over, right? I think that's kind of the industry dream has that we have that fine-grained control and can really narrow down access end to end. But it's tough, right? You have to have an unprecedented understanding of the applications, what the data is, where the data sources are, where the database is, what are the users doing, how are they doing it. Very few people have that level of insight. If anyone, right? And then you go to a place like Cisco, right? So 30+ year enterprise. We have a lot of assets that have been built over years. Mm-hmm. Some of those assets have, great support around it. A lot of, people that still understand it. But we have some, kind of legacy apps sitting there. So when you have an app that, frankly, the people that architected and wrote it 5-10 years ago aren't here to explain it, that's just this spiral vortex of problems that both your team and my team we're faced with. So in those cases, you're often going to do more harm than good, I'd say, right?
Or you're expending tons of time trying to figure out dependencies, so that and figure out dependencies so that you can build a policy that can be enforced in that segmentation model.
Yeah, and you're assuming that it's going to be static.
True.
right? Like, okay, we could get it working in the clean room, right? Everything's perfect.
I think we've already established that the world of static things is
Yeah.
long gone. Like cloud started making that disappear a long time ago. AI is accelerating
Yeah,
that.
it's here's how it's supposed to work, and then
Yeah.
like, holy crap, somebody just threw all this AI stuff at it. And We didn't know that was what they're gonna do, and now you got to like re-architect or rebuild, and like it's I think that's as far as I've seen, and I think as we work together on those things, that's the big challenge there, right? Because you could introduce so much. Call it frailty, or it becomes a fragile implementation now that every time you change something, the likelihood you're going to break something else accidentally just skyrockets.
Okay,
right?
so we've been talking about a problem here for a couple minutes. The problem is segmentation and the challenges with it. Let's talk solutions. In my opinion, AI has something to offer here. So when I think about, like, Cisco has products in this space around segmentation, specifically Cisco Secure Workload, Hypershield. These are products that are meant to address these kinds of segmentation problems. I think the secret sauce here is going to end up again being AI. We talked about the dependency mapping piece of segmentation. Like, you have to map the dependencies before you can segment the application, right? But mapping the dependencies is really, really hard, right? Like, my team would have to look at a ton of NetFlow in order to figure out how to map those dependencies out. That might take days or weeks to do that. But if I have a machine doing that work, an agent doing that work might happen overnight or in a matter of minutes. And I think, too, in this world of constant change that we've been talking about, an agentic way of detecting changes to applications that force an adjustment to policy, that is, the day 2 problem that I think about a lot. Is like, okay, you get this right day 0, and day 1, you got segmentation right. But day 2, it starts to change and evolve as the application changes and morphs, and the other applications around it start to change. So I'm really feeling kind of good about what the future might look like here. It might actually help us really crack the nut on microsegmentation.
And what I'm kind of excited about is my job as a protector of the enterprise. We've building out our attack surface management program. As part of that, it's really focused in on, let's move away from kind of the legacy. Let's just not wildly scan stuff and throw a bunch of vulns at you. At the end of the day, what I really care about is, like, how do I make sure, like, I've got that hard candy shell around Cisco, wherever Cisco is, right? It's not just it's not an enterprise that just has walls around a data center and that's everything is in there. Like, our walls are everywhere. We've got public cloud, we've got users working from everywhere, we've got data centers everywhere. I'm focused in on, like, understanding more specifically, how is that attack surface changing? Not point in time, once a year I go look at it, like, regularly, daily, more frequently than that. Like, to me, that's where it gets exciting. It's like, how do we take that data, working with your teams, and, like, hey, we see all this happening, like, let's go react. Like, these are where I think, as the systems get more interconnected, this is how it's just going to like get better and better over time. Because, like, we've got a lot of telemetry and real-time visibility from where we have sensors, but now we combine that with what we can see from the outside too, and it becomes like this, like, virtuous cycle, I think.
Right, you guys are swimming in data. Tremendous amounts of telemetry coming in. I mean, obviously from the network, it's a huge source of telemetry. The network itself is one giant sensor, right? But you've got telemetry coming in from all over the place. You're feeding all that into Splunk, right? And the more ability you have to agentically tap that data, and use that to adjust our approach to securing the network, for example, the faster we can react and adjust to that changing attack surface.
But it's interesting for us. So, like Cisco, we're a tech company, right? We give a lot of flexibility and power to our users, and we have a lot of technical users here, right? So, they do some really interesting stuff from time to time, right? And they don't always do it in a production environment, but sometimes they have access. So, we talked a lot of, like, all these conversations around what do we do to protect, like, our production systems, our production data. But we also have labs. We also have all these DMZ assets that are sitting out there on the internet edge. We have all these cloud assets, and it's like, that's the other place that I think is we're going to see a lot of value in, is like, helping understand how all these things are actually connected, because I think we have this notional idea of what the architecture is supposed to be, what's supposed to talk to what, but it's like that human piece that we've historically had, which is like, oh, somebody left like IP somewhere, or there's like an extra permissive ACL somewhere, and like, oh, that asset was never supposed to be able to talk over here.
Right.
That's the stuff that I'm like also really excited about. Like, how do we continue, once again, know what's supposed to talk to what, have really good governance around that, really good visibility, and be able to react like almost real time.
Yeah. Okay, so another thing on my mind, our hybrid workforce, right? We talked a little bit about the fact that probably at least half of Cisco at any given time is not working from a Cisco site, but is somewhere else at home, on the road, whatever it may be. So huge amount of hybrid work going on in this company. We secure that using SSE. Right? Cisco's solution in that space is Cisco Secure Access. So not only do we have kind of the old school VPN capability as part of Cisco Secure Access, but we have Zero Trust Network Access in there as well, which is, super interesting. Like that gives us the ability to apply consistent policy to anyone accessing a network from any location. The one thing I wanted to ask you about, though, was how is Cisco's Secure Access helping to secure Cisco's own consumption of AI capabilities? Like, we're out there consuming AI just like any other company. We're out there consuming from all the different AI providers out there. Do you want to just talk a little bit about what we're getting out of Cisco Secure Access that is helping keep Cisco secure?
Yeah, so before I get into that specific answer, I think just to highlight, Cisco Secure Access for us has been really, I think of it as it's a platform, it's a Swiss Army knife, it's a lot of things, right? You just talked about it's VPN as a service, right? So we're able to now move traffic from your legacy head ends, and now you can scale. You've got flexibility and diverse connections that you could stand up, and you've got more elastic capacity, zero trust access. Now, once again, we're not running gateways at our edge. We're running that through kind of the big router in the sky. That flexibility allows us to change how we deploy technologies, how we make it available.
How we integrate acquisitions might be another good one,
right?
too.
You get that day one support. You don't have to go do the big forklift upgrades and do a bunch of gymnastics to get people to connect. But it's a platform, right? Because we had those capabilities, but then as AI came at us, right, and we're trying to figure out how do we get visibility and governance and control around AI, one of the things that Cisco Secure Access had was like, we already had a footprint. We're enabling new capabilities. We're expanding what we already had to build off of. So, the time to deploy these technologies is like shrinking, and it's actually a lot of flexibility for us now. Because now we've got a footprint, so we can.
You don't have to roll out new hardware.
Yeah, exactly. I didn't have to go license. Let me go find a new vendor that's doing a very niche thing. And then add another agent, right? Like, look,
or sign another software contract.
Yeah, I'm talking to IT, right? Like, one of the things you guys have drilled in my head is like, you can't just always add more agents on my asset, right? Laptop, server, whatever. There's an impact. There's a performance. There's a serviceability. There's operational overhead, etc. CSA, or Cisco Secure Access, gave us the footprint already there. It's a configuration we push down, right? And now it gives us the ability to have that. Let's be a little bit more surgical, right? I don't care about seeing all the traffic off your laptop, John. But I do care if you're using AI tools that we haven't officially sanctioned or licensed, and you're not using public or synthetic data through it, right? So those are the things that we can now see, control, lock down,
right?
And it gives us like this flexibility and visibility that we've never had.
Right. And so our teams were working really closely together on this recently, because we'd rolled out Cisco Secure Access with the goal of primarily going after VPN and ZTNA, those particular use cases. But as we were going after them, we realized, oh crap, we've got a big problem inside the company and a big risk around the consumption of AI.
It's oh crap. It was like, oh shit, Jack's coming to me with a new requirement, right? Because I think that's kind of how it landed, right?
Totally.
Which is
landed.
Like totally off the radar.
Right.
As you said, we had zero trust
access
and VPN. That is the program.
Yeah.
And you're running the program, and like we're at the steerco meeting. I'm like, hey, can we do this thing with AI?
Yeah,
You're
you
like,
basically said, can we pivot?
Yeah.
And we said, yeah, we can pivot easily.
Yeah, and I think that was the cool part about that project, which is, it actually brought a lot, like it's IT, security and trust, but it's also the security business group coming to the table because it wasn't there off the table ready to go day one.
Yeah.
Like there's a lot of work we had to do. We figured out a lot of things. We did a lot of tuning and troubleshooting, built a lot of features, but right now what we have is like a full enterprise-wide, all the users, contractors included, have it deployed.
Right.
It's been pretty amazing.
So to sort of distill this down a little bit, what you got here is basically Cisco has governance around AI consumption, right? Yeah. Cisco decides what AI products out there are sanctioned, right? And then we have the ability to enforce those policies that are being created around what's sanctioned versus unsanctioned.
Correct.
We have the ability to enforce those policies in the network, in Cisco Secure Access, right? So that's huge as far as ensuring that intellectual property in Cisco isn't leaking out, to unsanctioned AI providers.
And I think the beautiful part of it is, and I know I just use beautiful and technology together. It's probably kind of weird to say it that way, but the cool thing that we can do, like we have that ability to do conditional access now, right? Where engineering teams may have the need to use very specific tools that are licensed for them to use, but we don't want everyone to use those, right?
Right.
Or there may be like a team doing AI experimentation. They're highly trained, understand what they're doing, understand what data to use what not to use. But those are tools that we don't necessarily want to make available to the Gen Pop user.
Yeah.
Right? And so we have the ability to really from the AI general user, you and I, to the AI developers that are building these things, to the AI experimenters and researchers, we could cover the gamut of those.
Yeah.
And we don't have to treat everybody under one set of policies now either. Yeah. And I think that's historically been the heavy club of security is you kind of have to peanut butter paint across everybody. But here what we're doing is we're a little bit more surgical.
Yeah.
Because at the end of the day, we just talked about how great AI is. We want to make sure we can use AI to make Cisco great and make better product and to make our customers happier and things like that. But we've got to do that in a controlled fashion, right? Yeah. We can't just open the floodgates for everybody.
Yep.
But it's not the only place we need to think about segmentation. So where else is your team deploying different types of segmentation technologies and strategies across?
Yeah. So segmentation obviously exists outside of the data center. If you look at our campus and branch environments, what you're going to see there is a similar kind of segmentation approach to what you'd see in the data center. But in the campus and branch world, it looks a little bit different. So in the campus and branch world, what we do is we're managing the configuration on all of our wireless LANs and our access switches through Catalyst Center and through Meraki Dashboard. So we're getting the right security configurations on these devices through a centrally managed controller-based approach, right? And then every single access switch port, even in a building like this, every single access switch port, every wireless LAN is basically requiring authentication and authorization, right? So you as a user and your device are authenticated onto the network, and then we apply an access policy to you, to that combination of identities, that user and device, all right? That's done using Cisco's Identity Services Engine, ICE. Okay, ICE is basically the policy manager there and deciding what policy you get when you enter the network. Once you've actually entered onto the network, ICE assigns a tag to all your traffic. And that tag represents your identity as a user and the device that you're on. And that tag gets carried with your network traffic all throughout our enterprise network. And then what we can do with it is we can apply policy based on that tag anywhere in our network. So for example, we can apply policy going into a data center, we can apply policy going out to the internet, we can apply policy going into a lab. We have a lot of flexibility on what we can do here. And so it's that combination of access, network access security, plus segmentation that gives us a lot of sort of end-to-end power over security in the network.
So it's interesting, as you lay all of those pieces out, what kind of hits me is that's almost impossible to start bolting on.
Right.
I would have to bolt on some security into the data center. I got to do it at the edge. I've got to do it on my endpoints. I've got to do it everywhere. But I think that's the power that we get through Cisco, which is our ability to have it embedded in.
Yeah.
Right. Like this is like just it takes another piece out of the equation for us. Right.
Yeah.
We have those capabilities in
Yeah,
front of
yeah.
us.
It's embedded and it's end to end. That's the magic here, and that's what makes it actually simple to manage. So the ability to get from one end of our network with a common security architecture to another end of our network, whether it's a campus or branch to a data center, whether it's a data center to the internet, whether it's a lab inside of Cisco into a campus or branch, any of these major segments in our network, we have a common security policy and strategy around that. And that's key to actually making this work in a relatively simple and easy to manage way.
And we also have we've got a plan, and we've got the roadmaps, and we're building the future state of technology too, right? Whether it's our what we're doing on the Wi-Fi side with our access points or our smart switches, our smart routers. We've got we talk all the emerging threats around AI, but we haven't yet scratched the big thing out there that's going to break the internet, or that's going to break encryption, which is post-quantum, right? So there's a lot on that conversation too. That how are you thinking about post-quantum right now in terms of being the network operator here at Cisco?
Yeah, so it's kind of a funny question because I'll probably turn it right back around on you. I think about post-quantum by what kinds of security risks arise with it. And then I look to you to help me, understand those risks a little bit better. So the first thing I asked when we started talking about post-quantum was, hey, I'm going to need your help figuring this out. I need to see where you're going from a policy and a standard perspective to figure out what I need to do on my side. And so you and your team got out there and really looked at what was going on across the industry and built policy and standards that now help me prepare for the post-quantum world and what I need to do with cryptography in the network. So what we're finding here is that we've got a point in time where we all agree we need to make that switch to post-quantum cryptography. We need to be quantum safe, right? But in the meantime, we have to get ready, right? We have to get ready with the right protocols, the right standards, get those in place, right? And in some cases, that may mean doing image upgrades to get the right capabilities. In some cases, that may involve doing hardware upgrades to get the right capabilities. So we think about this, and we're thinking about this really now based on a risk that you shared with me a while back, which was harvest now, decrypt later, right? Yeah. The ability, like you were telling me, look, the bad actors can capture our traffic now, hold on to it, wait for quantum computing to get more mature, and then decrypt that traffic later, right? So even though these quantum computers aren't out there today doing their thing, they're getting there. They're not there today, but even though they're not there today, there's a risk today about around encrypted traffic moving through the network, and that at some point in the future you can decrypt that and see what's happening in this network and within the company.
And I start breaking it down, John, in terms there's two main sets of risk I think about in PQ, like post-quantum crypto, right? There's the harvest and decrypt, right? There's the also the encryption and the security that we built into the platform itself. So how do we maintain control and integrity of the asset or the router or the switch or the infrastructure, right? We've just talked for a while, right? How important the infrastructure is and the secure infrastructure specifically to, kind of that underpins all the communications and all the data flows, etc. The other part that's important there, like post-quantum, we've got to protect the integrity of those boxes because just like you can harvest and decrypt, what if you can now break the trustworthiness of the infrastructure itself, right? So that's the other part that we're doing. So as you mentioned, right, we are building new hardware capabilities to be able to go resist, those quantum attacks. Reality, some of those we can do in software. Some of those do require some hardware changes, right? And this is where, as the standards are being set, this is now the race. But I think what's top of mind for us, it's not just one problem space. It's not just the harvest and decrypt. That's the normal place everybody goes. But we know as a critical infrastructure provider, right? Like our part of our world is like, let's protect
Yeah.
the environment that we help enable,
Yeah,
right?
yeah,
And
yeah.
attackers
Totally.
are going after that infrastructure. It's not just going after the data.
Oh yeah. So let's break this down and make it even simpler. Really, this all boils down to two things: secure communication across the network, right? We need to encrypt that in a way that's quantum resistant, that's quantum safe, right? The other thing we need are secure products.
Correct.
Products that have secure boot and secure storage, and that can't be compromised through quantum computers.
That's exactly right.
That's simply what we're talking about here,
Yeah.
if you boil it down.
That's a great way. That's an easy way to describe it. I can explain that to my kids, right?
Yeah.
So, one of the things that, is we've gone through this conversation, obviously we work a lot together, right? And I'd argue that like the relationship that we have between IT and our security org at Cisco is kind of unique, right? I don't know that every company has that same relationship. There's a lot of, there's friction, right? Because oftentimes like
Healthy tension.
Yeah, there's healthy tension,
Yeah,
right?
yeah.
Like we have different missions ultimately, like a lot of availability and uptime for your side. Like mine's to protect the enterprise.
Yeah.
But the reality is these are intertwined concepts, right? And I think our partnership's shown that like why it's important for us to work together to drive the value and the outcomes. And I think that shines through when we talk to customers, right? So, what do you think is like probably the biggest thing that our customers are asking us about, right? When we
Well,
get in front of
definitely.
them, right?
Like what I get asked a lot is, show me your org chart. And a lot of times what they want to see is they want to see how the security team, like your team, where they sit organizationally compared to my team. And then they start asking questions like what do they do versus what do you do? Do you guys work together? If so, what does that look like? And a lot of times I'm describing this to an audience, of Cisco customers, where both like maybe a CIO and a CISO are in the same room. And I think as I describe what this relationship, what this partnership looks like, oftentimes they start to kind of like go, wait a sec, maybe we should think a little bit more closely about partnership here. Like the way that we have been partnering up until now has been fine, but this world is changing.
Yeah.
It's moving much more quickly. We need to tighten up. We need to get better at this. That's a conversation that often plays out that I find with peer IT organizations and peer security organizations in the industry.
Yeah, I think I go back to security being a team sport, right? So I can't win if you don't win,
Yeah.
right? This is like we have to cover each other's backs. We have to complement each other. Like your team strengths complement my team strengths, and like I think that's the magic partnership that we strike here, where it's not I've got to win. That means you've got to lose, John.
Yeah.
Right. And we're not, obviously like there's always budgets and resource conversations that we've got to work through, but ultimately we are aligned to really protect Cisco, protect our customers, protect our products, and that's how we do it together.
Yeah.
At the end of the day.
Absolutely.
Yeah. Well, so John, with that, it's been fun. Great conversation. And,
it's flown by.
yeah, we'll do this again sometime.
That sounds great.
All right. Thanks.